Hi, my name is Doug. I'm going to be talking about building with agents, things to watch out for. There's going to be super high level to leave time for questions for everybody at the end. But yeah, quick about me. I said I'm Doug. Hi. I was OpenAI's first London hire here. I was an engineering lead and a research manager within OpenAI's a human data team. YOLO quit after 2 years, so I quit roughly March of this year. And then I founded a company called Lightfern 3 months ago. One of my co-founders, Marcus, he's over there. But today here, I'm here to talk about agents. Agents are pretty awesome. They can do a lot of stuff, right? There's Lovable, Claude Code, and etc. And I think there's this kind of proliferation, especially when it comes to coding, in terms of how capable these agents can be in terms of helping you just build a crazy amount of stuff. But they can also get things really, really wrong. And when they get them wrong, there are very serious real-life consequences. Now, it's obviously really stupid to grant prod access to sort of a coding agent. It's similarly like, even if I'm the CEO of Lightfern, like I actually don't have direct access to take down our database. That's probably a good thing because it's easy to like make mistakes. But essentially, like I'm here to kind of share, hey, like why do these things happen and how can we like deal with it? So super high level, like how do we train agents first, right? Training agents, very typical, reinforcement learning overview. You give the agent some sort of a prompt. There's some model in the middle that tries to, fulfill that prompt as good as it can, right? You score some sort of a result at the very end, and then you basically boost the probability of that agent or that model in the middle doing the right stuff. And you basically just have to do this like, 100 times up to like, I don't know, 100 million times or so, depending on how good you kind of want your final model to be. And during that time, you just essentially sit and wait for a while. And your reward can really be anything. Your reward can be, hey, like, given a multiple choice, right? Select the correct answer, right? Very classic, RLHF or reinforcement learning. It can be passing a unit test. It can be other ML grader models, which kind of make for a lot of interesting cases and things you can actually train with agents. And you can use various algorithms in the middle to train these models, including PPO, GRPO, and so on. And the problem with why I think agents exhibit catastrophic behavior is essentially reward hacking. And I've actually experienced this myself. I'm pretty sure a lot of people have probably, if you're kind of using coding tools. But essentially, you ask, let's say Claude Code or whatever, to say, hey, can you actually fix this test? And it will just straight up go and delete the test for you. And it'll say, hey, cool, like, I've fixed this. And why does this happen, right? Essentially, I think my hypothesis is basically poorly specified rewards during training. And it's actually a lot harder to solve than you think. So if I give a prompt saying, hey, this test is failing CI, can you fix it? It can delete the test. It can delete the CI script. It can keep the CI script, but make it not run on your PR. It can skip execution by marking your test as flaky. It can change the test to always pass by basically like hacking up the test. It can hard code responses in your code to make it match the test and so on. And so, given that, the current agentic models today, they all have these issues, the question is, well, how do you train better models? The first, and I really firmly believe in this, especially during my time at OpenAI, but still so now, is you really need an accurate environment. You need accurate state, actions, and rewards. And I think typically where things go wrong is either kind of capturing the environment in the world as a whole, or really kind of nailing the rewards itself. And obviously you need to add really, really high quality evaluations instead of, because even if you train something amazing, a lot of times people rely on vibes in terms of figuring out, hey, is something actually good or something's not really working. Accurate world simulators lead to much better models. That's true for not only for LLMs, it's true for, I think, for AI in general. So robotics, obviously this was the robot that NVIDIA demoed a couple of months ago. And they basically, the key breakthrough here is instead of actually training something in the real world, they were able to create physics simulators that were so realistic in terms of everything, in terms of physics captured, in terms of the rendering itself, to be extremely lifelike, and that transferred really easily to the real world. Waymo, they have something called Simulation City. On the left is a real picture of real video of San Francisco. On the right is actually a simulation, and you can actually see how close these are. And so, yeah, and same thing, right? Dota 2, OpenAI did a fantastic work there with OpenAI 5, and obviously Google on StarCraft. And in these cases, you actually had access to the underlying game binaries and the game state so that you could actually fully capture whether it was a specific reward or kind of exactly what was going on in the game, to be able to capture that just like 100% as accurately as possible. Because any bug or deviation there, it's going to lead to some subpar performance that's going to come out at your model. And one of the reasons why I think coding agents have really taken off far beyond everything else is kind of the availability of the data when it comes to training, right? There's a huge training corpus already available. We have lots and lots of open source software. You can go to, I don't know, GitHub or GitLab or whatever, and you can see all of this just open source stuff coming through, and there's this code is really readily available for people to potentially train on. You have pull requests that are, very highly structured, especially if you're looking at high quality open source repos. I think, and some key things, I think Dockerization actually played a pretty key role, because if you have reproducible environments, your agent can always, you can expect your agent to start with the same initial state of, let's say, a working repository, as opposed to like navigating that sort of uncertainty around in that space. And unit tests, right? In this case, if the unit test, if your unit test itself is kind of the grading function and say, hey, I've got this bug in this code, can you go fix it? All you have to do is just get the agent to try again and again and again. And eventually it's going to get some of those tries right, and then you can boost the probabilities up of those. That's obviously not the case, I think, aside from coding. There's very, very little real world data in terms of how other people do their jobs, whether you're thinking about a lawyer or accountant or whatever. I mean, sure, people go through courses for these things, but there's less of a record compared with, let's say, a pull request of, hey, this was the issue I found, this was the decisions I made, these were things that I tried, and this was how I tested it. So, given that the technology is here today where, there's still, their agents are fantastically capable, but there's also this very high chance of catastrophic failure, right? What is the right way of working with them? Now, this is all entirely a personal opinion, but I think the first thing is like validation is really critical. And one thing I think that Claude got really well, compared with my experience with Cursor early on, when I asked Cursor to do something, it would just go. Like there was no sort of interruption in the middle, especially when I started using its agentic modes early on. And I very quickly turned myself off of that. But I think one of the things that Claude really nailed is essentially just making sure you're asking the user for permission every time you kind of make anything that is even slightly potentially risky. And I think another thing that people don't really think about as much is, what is the user currently doing there? Because, we use technology, we're building this technology all the time, and we're very deeply familiar with how it can succeed and what context it has. But for a typical user, right, they're going to be looking at this piece of software that you built, and they're going to say, hey, can your agent fix this thing that I'm seeing? Or, and it's really, really important for the agent to actually be able to see exactly what the user is seeing. I actually see this failure mode in a lot of products where you'll just ask it for some obvious question. From the user's perspective, it's completely obvious that, hey, you should be able to see what I'm seeing. But that's actually, I think, not the case in 80% of products, which is pretty sad. And then it's really important to make it easy for people to verify agentic output, right? So think about, hey, what are the key flows that your agent might be doing? How can you verify that output? Is there some way of presenting that information to make it easier for people to understand, oh, okay, these are the changes I'm going to make, or these are the changes that I've made, and this is how you can review it. And aside from, obviously, front-end design, right, I think latency still matters a lot. I think especially with reasoning models, we've seen a huge jump in latency. But I still think that, if you fundamentally can achieve the same result for less time, it's just going to make for a more magical experience. That's me. Any questions? Feel free to come chat with me. Yeah.